So in this example, we're going to see the application of using greatest common factor. I will read the problem now. It says, a relief worker needs to divide 300 bottles of water and 144 cans of food into groups that each contain the same number of items. Also, each group must have the same type of item, bottle, water, or canned food. What is the largest number of relief supplies that can be put into each group? So you have two amounts. You have 300 and 144. 300 bottles of water and 144 cans of food. You want to find the greatest common factor between those two numbers, okay? So you're going to use the factorization tree to find those two numbers, right? To find that number, actually. So, as always, you can say 2 times what gives me 300, but the easiest is to say 3 times 100, 10 times 10, 2 times 5. For 144, we can say 12 times 12, 3 times 4, 3 times 4, 2 and 2, 2 and 2, right? Now we have done our factorization. We need to rewrite it in exponential form so it's easier for us to determine what do they have in common. So for this, you have 2 to the second power times 3 times 5. On this side, you have 1, 2, 3, 4, 2 to the 4th power times 3 to the second power. Now, we are looking for the smallest number they have in common. I know it says greatest common factor, which makes you think you want to pick the largest, but no, you're looking for the smallest. So let's start with 2. Right on this side, you have 2 squared versus 2 to the 4. You pick the smallest, 2 squared, times. Right here, you have 3 and 3 squared. You pick the smallest, so the 3. I have a 5, but I don't have a 5, so I do not pick a 5, right? So then you have 2 squared gives you 4 times 3, which gives you 12. So the greatest common factor between 300 and 144 will be 12. So that will be your final answer. And that's the number of groups you will need to put.